Alright, typically the first thing you want to solder are the lowest components on the board, are shortest in height, but usually before that you want to do anything that's surface mount. A lot easier to have a little more room to work on it. So I already got the chip on there. So I want to move on to the USB connector. Connector's centered on your pads in the back there. Then just solder one of the legs. It's about the only place besides the chip here that you'll have to use any fluxes on these small little pins. So just put a little bit on there. Alright, typically when you have the chip and the connector soldered, you can actually already plug this into the computer, and the computer should recognize the chip. There are drivers you do have to install if you don't have the Arduino environment installed already. The Arduino environment actually comes with the drivers in the downloader. You can also download them from ftdichip.com. Alright, next step is you want to solder all your resistors in. 120K and 4 1K resistors. I'll point out where they go just in case. Everything should be labeled on the board, and easy enough to find. A couple of things just to point out is these 2 pinholes here and these 2 pinholes here are the extra breakouts for the 18 mega chip. This is digital 10 and 11 and 12 and 13. 10 and 11 are pulse width modulation capable. 12 and 13 are not. 1 1K there, 1 1K there, 1 1K there, 1 1K there, and the 20K goes right here. Okay, you have all the resistors soldered, and remember there is no orientation on them. They can go in either way. It doesn't make any difference. Also, as I stated earlier, the 20K is actually what controls the brightness for the actual grid on the Arduino itself, and by increasing that you can actually dim it. If you wanted to get savvy, you could add a potentiometer to it, and that way you can control it by hand whenever you want it. I don't really see the point in it, but it is an option that if you wanted to. Next, we want to install the capacitors. There are 5 0.1 picofarad capacitors. And they are located here, 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 right here, and right here. And most of these are used just for filtering the power supply. The board would probably run without them. This one here is actually necessary for the reset control of the 18 mega when you try to program it. Alright, we have all our capacitors soldered to the board. And again, the orientation on these either, they can go in either direction. And next I would probably move on to the chips or the sockets. We'll start with the 74HC164, which goes right here. Make sure, as you can see here, there's a small little dip in the chip, and that should align to the dip in the board. Now what I like to do is when I solder in the chips, I'll actually put them all in place and solder just 1 pin on each corner, and I'll do the rest of them, and then I'll go back after I'm done everything else and then just go get all these extra pins and solder them. Not in the sequential order. I'll kind of jump around so we don't overheat the chips at all. So you may want to do 3 on this chip, then 3 on this chip, and then 3 on this chip, and 3 over here, and just kind of work your way around back and forth. That keeps any of the chips from overheating. If you're using sockets, it doesn't make any difference. Alright, next we'll move on to the 74HC165N. That chip goes right here. Alright, next we move on to the 18 mega, the 168 or 328, depending what you have. And that chip goes right here. And one special consideration is the fact that make sure you have your bootloader burned before you solder the chip in. If you're using a socket, no importance needed then. But if you're actually soldering it directly to the board, once it's in, you cannot program it. Okay, and finally, move on to the last chip, which is the Max 7219 or the Max 7221. Either one will work. I'm actually going to be using a 221 instead of a 219, just because I have some extra ones around, and just to show that it works the same. Alright, all the chips in place. As you can see, I just soldered one corner on each chip just to hold it in place while we solder the rest of the board together. Next, I would probably solder the resistor network in. And like I said, this is an actual 9-pin resistor network. They're a little bit more difficult to find. You can find them at Mouse or DigiKey here and there. But if you have a 10-pin one, the easiest way to identify which pin to cut off is every resistor network should have a dot. And that dot indicates that is the bus pin. These are all the resistors. This is the common connection. And this dot is represented as number 1. And you can see on the board there's a number 1. It's also closest to the label of 100 kilo ohm. And so you'd want to be cutting off the last pin, the one farthest from the dot, if you have a 10 pin. Alright, next I'd probably recommend soldering in the headers, if you have right angle headers. If you have straight headers, leave them for last. Okay, I have my headers in place, and again I did this the same way with the chips. Simply soldered one corner in each one. Usually anything that has a lot of pins like this, that's what I do. It's just to solder one corner in each one and assemble the whole board. Then you can just leave it flipped over and just solder along and work your way through it. Next, you have the two LEDs. Now the LEDs do have a certain direction that they have to go in. There is a positive and a ground. The positive terminal is always longer than the ground. And on the board, you can identify that by the fact, I don't know if you can actually see in the video or not, but on the board, if you look, you can see one side is flat. And that is the ground side. Typically, your LED will have a flat side or a flattened mark on it. It should always align with the short pin. Either way you identify it, the short pin always goes on the flat side. And on this particular board, my logic board, on both of them, it is towards the inner side. From here to here, here to here, you can see it's towards the inner side for the ground pin. Okay, and finally, I have one component left, and that is the resonator. Remember, they use 16 megahertz, and it can go in either way. Doesn't make any difference. Alright, just to show, for those that decide to use the module for the USB connection, there's the module. You can use a socket. The socket would go right here, right in place of these two. You wouldn't put these two on there at all, don't need them. Or of course you can solder directly to the board, and it would go right there, like so. Of course my connector is getting in the way, but you get the general idea. Otherwise, the board is complete. We have all the parts in place. The only thing we have to do now is go around and solder all the pins that I have left, and the board will be finished.